All right, welcome back, guys. So now we're going to be looking at how to actually graph each of these functions, the rational reciprocal functions. So again, one of the things that we want to recall is that our general rule for transformations for these guys, right? So as far as transforming off of the parent equation, which is 1 over x, all right, our general rule for transformation is f of x is equal to either a times 1 over x minus h plus k, or it's a over x minus h plus k. And again, the h, and the k act just like they normally would, and so does the a. So let's look at this first example. Okay, so if we have 1 over x minus 2 plus 3. Okay, so remember that originally our asymptotes were at the y-axis and the x-axis, but now everything's just going to shift, all right, up 3 and to the right 2. Okay, so again, this tells me that I'm going to go, that this plus 3 tells me I'm going to go up 3, and this minus 2 tells me I'm actually going to go to the right 2. So my entire graph is just going to shift that way. So if I'm going to think about, okay, well, where are my horizontal asymptotes, right? Because again, that's kind of the first thing that we want to do, is our HK, essentially where they intersect, is going to be at positive 2, positive 3. So I'm going to go 1, 2, up 1, 2, 3. So that's where our horizontal and vertical asymptotes are going to intersect, because, right, in this case, we have a horizontal asymptote at y equals k, and we have vertical asymptote at x is equal to h. Okay, and that's what we talked about in the last, a little bit in the last video. So in this case, we have a horizontal asymptote at y is equal to 3, and we have x is equal to positive 2. So I'm going to go ahead and graph those first. And again, we're going to use dotted lines for asymptotes so that we know that they're not actually parts of our graph. Okay? And so this is my vertical asymptote at, horizontal asymptote at x is equal to 2, and at y is equal to positive 3. Sorry, that I switched those up. Jeez, Mr. Kiefer. We have y is equal to positive 3, and x is equal to positive 2. Okay, so now from here, I'm going to graph this function just like I did before. Right, before I went right 1, up 1, and then I went right 2, up a half, and then I went right a half, up 2. I'm going to do the same thing on the left-hand side. So I'm going to go left 1, down 1. I'm going to go left 2, down a half, and left a half, down 2. And then I'm going to graph this thing so where it looks like it's going to get really, really close to this asymptote, but it's never actually going to get there. And I'm going to have that little bit of a curve kind of as it gets towards the center, or towards the point of intersection of the two asymptotes. And then I'm just going to graph this thing just like this. I'm just going to draw the general shape. Okay? That was actually not too bad. Okay? Now, as far as the defining characteristics are concerned, right? So this is where things start to get a little bit tricky. So for our domain, right, we can see, right, that out of everything, right, as I'm moving from left to right, we can see that our graph is essentially going to be defined everywhere except for this point right here, which is at 2. Okay? So our domain is actually going to be from negative infinity to positive 2. Again, we're not going to use any brackets, right, in union with positive 2 to positive infinity. So a way that we can kind of think about the domain, right, using kind of our examples before, is it's always going to be negative infinity to h in union with h to positive infinity. Okay? And then our range is going to be very similar. Okay, so our range goes up from we start at the bottom, we go up, so from negative infinity, and then the only break that we have, the only value that we actually can't ever equal, is positive 3. So our range is going to be from negative infinity to positive 3 in union with positive 3 to positive infinity. And how that's going to look too, right, for our range, is it's gonna be here. I'll write these both on the other side. Sorry. Okay. So our domain was negative infinity to h in union with h to positive infinity, and then let's go orange. Our range for k is going to be our range is going to be from negative infinity up to whatever value k is in union with k to positive infinity. Okay. So now moving on for increasing on and decreasing. In this case, right, no matter what, from left to right, we can see that our slope's always negative, so we're always going down. So this function in and of itself is actually never increasing, but it's decreasing on the entire domain. So it's decreasing from negative infinity to positive 2, and then from positive 2 to positive infinity. Okay. Oops, that wasn't supposed to do that. All right, horizontal asymptotes and vertical asymptotes, we've already talked about that. So a horizontal asymptote, for our parent function, right, one of the things that we want to talk about is increasing or decreasing. It's always going to be increasing or decreasing on the domain. So it's going to be one of these two on the domain. And how to tell will come from our A. So then we'll talk about that in just a minute. So for our horizontal and vertical asymptotes, all right, we know that our horizontal asymptote at y is equal to 3, and a horizontal asymptote at x is equal to 2. And again, remember, this comes from the horizontal asymptote at y is equal to k, and our vertical asymptotes come at x is equal to h. Okay? Again, transformed off the parent function. Then for x and y intercepts, this is kind of where we have to solve. So let's get that for just a moment, and let's just kind of tell everything that we can from here. We know we have no maximum or minimum value. We know that this function is 1 to 1. We know it has non-linear slope. All right, our vertex, remember, is not our vertex, and we're going to cancel that word out, but it's still going to be at positive 2, 3, because it's always going to be at whatever we're always going to identify here, our HK. Okay? Oh, sorry, that should be a 3. Erase. There we go. Okay. And then our axis of symmetry is none. We're going to put none, even though there actually is an axis of symmetry with these ones. It's just a little bit more funky. Anyway. So we're not going to worry about that as far as this year is concerned. Okay. Now our x and y intercepts. Why does it keep doing that? Come on. Our x and y intercepts. Once again, we're going to have to come on. Once again, we're going to have to set y equal to 0 in order to find x, and we're going to have to set x equal to 0. X equals 0 to find our y-intercepts. So let's kind of find our x-intercepts. So our x-intercepts, we want to set y equal to 0. So let's go over here. Okay. We'll go x-intercept. All right, so we set y equal to 0, so it should be 0 is equal to 1 over x minus 2 plus 3. I'm going to subtract 3 from both sides. I get negative 3 is equal to 1 over x minus 2. All right, now this is where it's going to be kind of funky. Right, what I'm going to do is I'm going to multiply both sides of the equation by x minus 2. Okay, and so again, we're going to kind of do a little bit of a cross product. But actually, yeah, let's think about it that way instead. No, stop doing that. It's the same idea, just we're going to think about it a little bit differently. Actually, we're going to think about it kind of like this. And then we're going to do our cross product property, which is essentially we're going to multiply and we're going to multiply. Okay? So what we have is negative 3 times x minus 2 is equal to positive 1. Right? Now we're going to divide by negative 3. And we've got x minus 2. Actually, let's distribute first. That might just be easier. So we're going to do negative 3x plus 6 is equal to 1. subtract the 6, and I get negative 3x is equal to negative 5. Divide by negative 3, divide by negative 3, and we got x is equal to 5/3. Okay, and so that's where I'm going to cross the x-axis, which is just right here. Okay, so I actually do have an x-intercept at 5/3, 5/3, 0, or x is equal to 5/3. Now for the y-intercept, this one's not going to be quite as easy as it has been in the past. Right? And so for y-intercepts, I'm going to do the same thing as I did before. I'm going to set x equal to 0. And I should get y is equal to 1 over 0 minus 2 plus 3, which is going to be y is equal to 1 over negative 2 plus 3. Now I do have to change the plus 3, and I have to make common denominators. So this is going to be y is equal to negative 1/2 plus 6 over 2. And this is going to, that means this is going to be y is equal to 5 over 2. So this is also going to be 5 over 2. Wait a second. Oh, sorry, that other one was 5 over 3. This one's going to be 5 over 2. Okay? And so we do have an x-intercept or a y-intercept at 0, 5 over 2, or y is equal to 5 over 2. Okay?